this time is integral calculus. The A part of it says the integral of exponential sine x cos x dx is what we are going to evaluate. And there is no other way for us to simplify this except substitution methods. As we know, we are going to look for the core function of this integral, the function to be integrated. Some people call it the substance to be integrated. The function to be integrated is called the integrand, whereas the solution of the integration is called the integral. So take note of that. We are going to investigate into this integrand and look for the core function, the most fashionable function, so that we can use it as u. So in this integrand, a fashionable function is this trigonometric function, which is sine x. So we can now say, let u be what? Sine x. In here we are going to perform an elementary differential coefficient. So if the preliminary or elementary differential coefficients of this will give us du, differentiate u we have du, differentiate sine x we have cos x, but with respect to x. So that is it. Or of course, at this point in time, we can make the with respect to x what we call dx as the subject of the formula. So definitely that will be what? Du upon cos x. We've set the subject for the with respect to s, which we call dx, is now du upon cos x. Since it is called substitution method, we are going to substitute the ingredients here into the primitive function. We are going to substitute the ingredient into the primitive function and see how we can reduce the integrand, thereby getting the value of the integrand. Let's see. Go back to the primitive function, which is integral of exponential sine x. Remember we said sine x should be u, so we put u there. Copy cos x. We didn't have absolute value for cos x, so we now say cos x. But we have a replacement for with respect to s, dx. The s was what? Du over cos x. So we carry this and fix that for this dx. And that is going to be what? Du over what? Cos x. In fraction, the number on top cancels the number below. So in our next step, we are going to have exponential, integral exponential u with respect to u. So we are now changing the function to u function with respect to u. Wish we can handle this. After handling this, we back substitute and the answer comes out. Rather than going this way and that, we have obtained the answer in a systematic manner. So the integral of u, exponential u, with respect to u, is of course itself exponential u. But this time around, since it is an indefinite integral, we have to introduce a constant of integration. So plus c. Then that substitute the value of u. What was our u? Remember, we were applying u to be sine x. So to cap it all, the answer becomes exponential sine x plus the constant of integration. And that is the answer. This is called the integral of the problem. I believe it is self-explanatory. It is solving it this way rather than going by the rigorous method. Understanding it in a systematic manner like this, you will always arrive at the true result. If you try to differentiate this, remember we did differentiation, you must go back to the question. So let's try and see. Differentiation of the exponential function, repeat the function, but times the derivative of the power. The power is sine x. So when you repeat this, multiply by the differentiation of cos sine x, which will give us cos x. So we take cos x and attach to this. You can see we go back to the question. So that is a proof that this is the integral of this problem. The second part of the question is the integral of this function. Look at the way they are putting the integrand. The way they are placing the integrand looks confusing. So you will write it in the way that you understand so that you can evaluate for the integral. Our sole aim of getting this solution of this integration is to find the function when differentiated will still give us back the question. So let's see how we can write this in another form. So that can be splitted. So students, when they see this, they will be confused. This is another way of writing it. Integral of 1 over x, Napierian log of x, dx is the same thing. Because if you multiply dx by 1, that is when that dx will come on top of this. So there's no problem about that. Now we are looking for the fashionable functions here for us to use it as u. So you have to be very, very technical in assigning the value of u, because if you give the wrong value for u, you will not get it. You keep on integrating, keep on integrating, you will not get the integral. So let's look at the integrand. Looking at the integrand, we can investigate to see that the most fashionable function to be used as u should be the Napierian log of x. It's a standing function. So we can now say, let u be the Napierian log of x. Some people call it natural log of x. It's still correct. Right. We perform the preliminary differentiation. At this juncture, remember we are still using substitution method. So our change in u will give us differentiating a Napierian log function is the differentiation of that function over the function itself. So differentiation of this x is 1 over the function itself, x, but with respect to x. Definitely we can say it is dx over x. Dx over x. So instead of using this, we will be using this. At that point in time, we can say my du is still dx over x. Remember, we have to make dx the subject. So we simply cross multiply. Our dx will come out to be x du. These are elementary differentials. Remember, after getting the elementary differentials, we need to back substitute it into the primitive function. This is what we call the primitive function, the main function. So let's take it back. The answer, therefore, the problem that was given, this over x ln x, will be what? We are substituting all these ingredients into the main function. So that's going to be the integral. Remember, we have the value of the x to be what? X du. So you put it back there. X du over what? X. Remember, we said our fashionable value function was u. So u stands for the x. In this ln x, we put u. Yeah, this function can be now reduced to noticing that this x and x is off. So you will have to reduce it into du over u. And this is a standard integral. Of course, we know this. Integral of du over u is of course the same thing as 1 over u du. This is also standard integral. Standard integral for this is the Napierian log. We give us the Napierian log of the base. plus a constant of integration. Remember, we were not working with u. You have to replace back. U has finished his job. Take it back to the primitive function. Finally, we summarize that it's going to be, from there, lim u. What was our value of u? Come back here. U was what? Lim x. So lim into lim x plus c will give us the value of the integral of this function. I believe you obtained that result. Cheers and remain blessed.